evaluating nth roots. We're evaluating nth roots. N stands for an unknown root. Okay? So different ones. We're going to simplify expressions of the form a to the n to the nth root. We are going to evaluate a to the 1n. It's a root, but it's not a square root because that n is there. And we're going to simplify a negative exponent. Okay. So the first thing I'm going to try is, what if we had a squared square rooted? What would we get, guys? A. That's it. They cancel each other out, right? What if I get negative a square rooted squared? What do I get? I get negative a, right? Because that negative is on the outside. Now, here's where it gets tricky. What if I get the square root of a negative a? What does that give me? AI. Good. If it's the square root of a negative a, you're right, it would be square root I. Square root a I, because that's not an a, negative a squared. All right, what is the square root of 0? Okay. What is the square root of 1? What is the square root of negative 1? Good. Okay. These are all just, you guys remember this, right? Thanks. All right. So, let's look at what would the cubed root of a cubed look like? The cubed root of a cubed. It would still be a, that's right. Okay, those canceled each other out just like squared and square rooting. Okay, what if we have negative a cubed cube rooted? What would we get? We would get negative a. I know some of you are thinking, where's the I? But when we take something to the third power, think about it. If we go negative 1 times negative 1 times negative 1, what do I get? Negative 1, right? So you got to kind of think in that term, okay? It's going to have a real answers and non-real answers because of that cubed. All right.
So if it's like an even power,
if it's an even power, there would be an I. If there's an odd power, there would not, right? Okay, let's try this one. What is the cubed root of 27? What is the cubed root of 27? What times what gives me 27? 3. Okay, how would I put a cubed root if I had x squared and I get, that's the same thing as x to the 1/2. What would 27 cubed be if I was going to turn it into an exponent? The cube root of 27 would be the same as 27 to the 1/3 power. 1/3. So I want you to think of these radicals are the same as raising it to a fraction. Okay, they're the same thing. Okay, we're going to try another one. We're going to take 256 and raise it to the, and we're going to take it to the 4th root. That's the same as 256 to what? To the 1/4. Okay, but what's the answer? What times what times what times what gives me 256? 4. 4 times 4 gives me 16. Times 4 times 4 gives me 256. Okay, let's try another one, but I'm going to put something else in there and see if you guys get it. What is the cubed root of negative 125? Okay, first, what is that in terms of a exponent instead of a radical? Negative 125 to the 1/3. Okay, what times what times what gives me 125? Ignore the negative for a second. What times what gives me 125? 5. But it's cubed. It's a cubed root, right? So I can stick a negative in front of it. Okay, let's try this with letters.
Numbers are fine.
All right, we've got z to the 5th, and I'm 5th rooting it. What's my answer? Z. Done. Okay. What if I had a fraction? So I had 27 over 8, but I'm cube rooting it. What would I get? 27 over 8 to the 1/3 power, which would be what? What times what times what gives us 27? 3. What times what times what gives me 8? But can you break up 4? 2. So 2 times 2 times 2 gives me 8. I know. Luckily, you can do a lot of these in your calculator. Okay? All right. So what if we had 16 to the 1/2? What would that be in radicals?
2 square.
Which is what? What's the square root of 16? Done. Okay. What about negative 8 to the 1/3 power? What would that be in radicals? Negative 8 cube rooted. Yes. What's the cube root of negative 8? What times what times what gives me negative 8? Okay, ready? I'm going to stick some letters in there. Okay. (9z), but cubed rooted. What is that going to look like in radical form? So, what's 1/3? What times what times what gives me 9? This is tricky. There has to be 3 things. It's actually a decimal. It's 2.08.
That's not fair.
Z to the 1/3. You can stick it in your calculator. You could stick 9 to the 1/3 power in your calculator. Okay. We're going to try a couple tricky ones. You ready?
Wait, I'm confused. Why is there a 1/3 of the 2.08?
Because while we can take 9 to the 1/3 power, do you agree we can't take z to the 1/3 power? Because I don't know what that is.
Oh, so it's not 2.08 z to the 1/3. It's 2.8 times z.
Okay. Let's try a couple of these. 9 to the 3/2. What would that look like in radical terms?
It's something squared, right?
So it'd be the square root of 9, right? Because this tells me, the bottom tells me what kind of root it is. And what does that 3 tell me? It tells me it's
Positive.
to the 3rd. Okay, so what's the square root of 9? What's 3 to the 3rd? 3 times 3 times 3? Good. Okay, let's try another one.
Yeah, one
Is that what-
negative square root.
2 makes it the square root. This is the same thing as to the 2.
Oh.
Okay, but we don't usually leave it there because it's square root. But it's always been there.
Square root.
Okay, so we've got negative 25, 5 over 2. What does that look like in radical terms?
Square root of negative 25 to the fifth.
Okay, if I stuck that in my calculator, what would it tell me? Try it.
It tells us
Try it. You want to say that again, Gabby, but louder? Right, it's going to tell you impossible because you can't have a square root of a negative number. So what is this going to be? What's the square root of 25? And it's going to be 5 what? Okay, and what's 5 times 5 times 5 times 5 times 5? 3,125?
She typed that as a calculator.
Wouldn't it be I and this?
No. Because remember, I is not a letter. It's not a, it's just changing it to negative.
That's debatable.
Okay. I think. Maybe you're right, Michelle. Hold on. Let's try this.
But no, because I is the negative one. Because
It is a negative 1, right? So it's negative 1 times negative 1 times negative 1 times negative 1 times negative 1, right?
oh, right.
Okay. What's 1 time? Negative 1 times a negative 1 is a positive. So negative 1 times 1 is a, so we get negative 1 times negative 1 is a, okay, and now we go negative 1 times 1 gives me a, so remember all of these really aren't negative 1, they're the square root of them, right? So it's still square root of negative 1, so we still have I. Because we could turn the whole thing negative, right? Because the square root of negative 1 squared is negative 1, right? And so we would have to change the whole thing. Right? Okay. Okay. Yes.
Oh, Lord.
All right, 3. We've got 2 times the square root of a squared cube rooted. What is this going to look like in exponent form instead of radical form? So we're going to have 2, right, in the front, parentheses, a 2/3, right, because we've got to have the 2 on the bottom. Okay. All right, one more.
Wait, so
We've got 3
wait.
x.
On number 3, so we square rooted.
This is supposed to be on the outside. Sorry, I wrote it wrong.
Oh, that makes more sense.
That makes, yeah, I did not understand before.
Sorry, I thought I changed it. I know, you're right, you're right. Okay, we've got 3x to the 3 over 4. So what does that show me, give me in radical terms? What kind of root is it? What's on the bottom?
4.
So the 4th root.
So 3x.
And we put it all on the outside and raise it to the,
Third.
there we go. Do we get that that is different than, what would that be instead?
That'd be 3 times.
3.
The 4th root
Yeah.
x times 3. To the 3rd, not times 3. 3 times the 4th root of x to the 3rd.
Yeah.
This one's for this. This one's for this. I just wanted you to see that there was a difference between the two.
That means it's something like that on the homework.
No, somebody asked me a really good question about that second hour. Like, why wouldn't it be this one? And so I went through and explained. Because see how the 2's on the outside here? I wanted to explain why the 3 was in the inside for there. Okay? All right, your homework is on the board. Again, it is page, and I'm going to write it down here again. 4, 17, 4, 8, 10, 12, 16, 18, 28, 34, 40, 52, 58, and 60.
Really? On the day I got a concert. Right. I don't even have my book with me.
There's a book right behind me. There's a whole.
Okay, but like, what if I don't finish it in class?
Right. So if you take a picture of it and do it, you should be able to finish it at lunch.